Hello students, welcome to Real Edutainment. Today in this session, we are going to take all the numericals from chapter number 3 of class 9th ICSE, that is laws of motion. So in this session, you will be getting to know the knowledge required and the associated formulas and everything, the numericals in this sessions. Okay, so without wasting much time, let's go to chapter number 3, that is laws of motion. Numericals part, that is, here is the first numerical, that is, a body of mass 5 kg is moving with velocity 2 meter per second. Calculate its linear momentum. Here the given data is body of mass 5 kg. We have got a certain mass which is of 5 kg, right, and moving with a velocity 2 मीटर पर सेकेंड, राइट. एक बॉडी है जिसका वेट है, मास है 5 kg एंड उसका वेलोसिटी 2 मीटर पर सेकेंड. दे आर आस्किंग अस टू फाइंड इट्स लीनियर मोमेंटम. सी, वी नो द फॉर्मूला फॉर लीनियर मोमेंटम इज P is equals to mass into velocity, right? So what is mass? 5 kg. And what about velocity? 2 meter per second. So what will be the final answer for this? 5 into 2 is 10 and kg into meter per second is kg meter per second. So this is linear momentum. Linear momentum P is denoted for linear momentum. Right? So what is the formula for P? P is mass into velocity. So from this sum, we come to know the formula for mass into velocity, that is linear momentum. Clear with this thing? Okay. Chalo. Next question. Next question is again a concept on linear momentum itself. Here the question gives like the linear momentum of a ball of mass 50 gram. Let us extract the data. Mass is given as 50 gram is 0.5 kg meter per second. The linear momentum of a ball is 0. And how it is represented as P. P stands for linear momentum, that is 0.5 kg meter per second. 0.5 kg meter per second. Okay, and now they are asking us to find its velocity. Earlier they have asked us to find linear momentum and they have given us the data like mass and velocity. But now instead of asking linear momentum, they have given us the data, they have provided the data with linear momentum and they are asking us to find linear velocity. How to do this sum? Same, similar to the last sum, that is just apply linear momentum formula. That is, linear momentum is nothing but mass into velocity. What is linear momentum given here? That is 0.5 kg meter per second. What about mass? Mass is 50 gram into velocity. Let us say this velocity is V only. Okay? They are asking us to find velocity. Then what will be the value of velocity? It's nothing but 0.5 kg meter per second upon 50 gram. Right? See, before putting or substituting the values into the formulas, first convert everything in terms of SI unit. Right? Here kg is in SI unit but gram is in CGS unit. Then how to convert CGS into SI unit? Gram to kg, just divide by 1000 kg. Then how much we can assured here? that is 0.05 kg, and they are asking us to find velocity, right? Even you can do here as well, but I'll suggest you to go with this thing only. That means just simply substitute the values. Now after conversion, right? So after conversion, let us try to insert the values. Like, what is momentum? Linear momentum is 0.5 kg meter per second. What about mass? Mass is in SI unit. Now we should take this value, not this value. We should take this value. That is 0.05 kg into velocity. Let us say it is v. Then what's the value of v? V is nothing but 0.5 kg meter per second upon 0.05 kg, right? Kg and kg will get cancelled. And how to extract this thing? That is 5 upon 10 into 5 into 100. 5 and 5 will get cancelled. 0 and 0 will get cancelled. The answer is 10 meter per second. The final answer would be 10 meter per second. Here, the required result. Getting, students? How we got this 10 meter per second? Understood? Okay. Next question. A force of 15 Newton acts on a body of mass 2 kg. A force of 15 Newton. Let's extract the data. Force of 15 Newton acts on a body of mass 2 kg. Right? यहाँ पे दिया है F का वैल्यू 15 न्यूटन है and mass 2 kg. Calculate the acceleration produced. See, this is the chapter name is laws of motion. So they are asking us to find the acceleration produced and they have given the data force and mass, right? So from second law of motion, that is the rate of change of linear momentum is directly proportional to the applied force, right? So through that we got the formula, that is F is equals to ma, right? This is second law of motion. So what is the value of F? 15 Newton. What about mass? 2 kg and acceleration a, right? Then what is acceleration? That is 15 by 2, right? So what is 15 by 2? It's nothing but 7.5 meter per second square. So the acceleration here is 7.5 meter per second square. Clear? 7.5 meter per second square, right? So let us try to recall all those three formulas at a time now. So first law, laws of motion. Laws of motion में का पहला law. What is first law? A body remains at rest or in a state of uniform motion unless and until an external unbalanced force acts on it. Means we can say from first law, F net force on a body is 0 if it remains at rest or in a state of uniform motion. The net force is 0 unless and until an external unbalanced force acts on it. Clear? Okay. What about second law? Second law is rate of change of linear momentum is directly proportional to applied force, right? So which is nothing but F is equals to ma. Okay, just now what we have seen. What about third law? Every action force has its equal and opposite reaction force. Every action force has its equal and opposite reaction force. So can I say action force is equal and opposite. So that's why I am taking negative sign. Reaction force. Every action force has its equal and opposite reaction force. Every action force has its equal and opposite reaction force. So these are the three laws associated for two laws of motion. Here we have got acceleration as 7.5 meter per second square. Okay. Chalo. Next question. A force of 10 Newton acts on a body of mass 5 kg. Find the acceleration produced. Same kind of sum as that of question number 3. Right. Here the force of 15 Newton acts on a body of mass 2 kg. Here the force of 10 Newton acts on a body of mass 5 kg. Find the acceleration produced. Can you people try it once? Okay. Chalo. Let's extract the data. Force is given as which law we are applying here? First, second, third. First, second, third. Obviously, second law of motion. Okay. Chal. The force of 10 Newton acts on a body of mass 5 kg. Force of 10 Newton acts on a body of mass 5 kg. Mass 5 kg. Find the acceleration produced. Find the acceleration produced. So F is equals to ma. Then what about A? A is equals to F by m. Right? What is the force over here? 10 Newton. And what about mass? It's 5 kg. So the answer would be 5 ones are 5 twos are. That is acceleration is 2 meter per second square. Acceleration is 2 meter per second square. Clear? Got this? Okay. Next question. Calculate the magnitude of force which when applied on a body of mass 0.5 kg, 0.5 kg produces an acceleration of 5 meter per second square. Very good question. Here they are asking us to find or calculate the magnitude of force. Right? Ultimately they are asking the value of force only, which when applied on a body means this force when we applied on particular body which is having a mass of 0.5 kg ultimately produces an acceleration of 5 meter per second square. That means when a mass of 0.5 kg has been applied by a force will produce an acceleration of 5 meter per second square. Then they are asking us to find how much force is necessary to produce this much acceleration for this much quantity of mass. Right? That is mass is 0.5 kg. Mass is 0.5 kg. Acceleration is 5 meter per second square. They are asking us to calculate the force. Then by second law of motion, as we all know, F is equals to ma. Second law of motion, F is equals to ma. What is mass? 0.5 kg into acceleration 5 meter per second square. This is 5 by 10 into 5. Right? So how much it will be like? 25 by 10. Right? So what is 25 by 10? F is equals to 2.5 Newton, which is ultimately the required answer. F is equals to 2.5 Newton. Getting? Okay. So it's as simple as using just a law, having the formula and substituting the values, right? So any problem, whenever you do any kind of numerical problem, so 4 things are essential to have the solution. First, understanding the question. Second, extracting the data. Third, having an obvious formula for that. And fourth one is calculation. So through these 4 steps, you can definitely get the result. Okay. Now, next question. Got this answer, everyone? Okay, next question. A force of 10 Newton acts on a body of mass 2 kg for 3 seconds, which is initially at rest, and calculate. There are few of the points which needs to be calculated. Okay. So shall we extract the data? A force of 10 Newton. That means they have given force how much? 10 Newton. Acts on a body of mass 2 kg. Acts on body of mass 2 kg. Okay. That means this much of force is acting on mass 2 kg for 3 seconds. Even the time is also mentioned over here. T is 3 seconds. Okay. A force of 10 Newton acts on a body of mass 2 kg for 3 seconds. Initially at rest. Initially at rest means U is equals to 0. Okay. So this is the data what we have extracted from the given question. Now, what they are asking us to find? First one, calculate the velocity required. That means they are asking us to find first one, final velocity, right? And change, second question, change in momentum. That means they are asking us to find linear momentum. Okay. Now, calculate the required velocity by the body. For required velocity by the body, how we can go? We do have force, we do have mass, we don't have acceleration. So let us first try to find acceleration. So F by second law, F is equals to ma, right? Force is 10 Newton and mass is 2 kg. By this we can find acceleration. So acceleration is 10 by 2. That means acceleration is 5 meter per second square, right? And through this acceleration, can I get the value of velocity? Yes. Simply apply acceleration ka formula, v minus u by t, right? So what is acceleration? How much is acceleration? 5. What is final velocity? Final velocity, they are asking us to find final velocity. What is initial velocity? Initial velocity is 0 by t. For how much time? That is 3 seconds, right? So can I say velocity is equals to 5 into 3, right? So velocity will be 15 meter per second. Velocity will be 15 meter per second. Clear with this? This is the required answer. 15 meter per second. Okay. Now next one. What they have asked us to find? Momentum. Change in momentum. That is, change in momentum is denoted by P. P is mass into velocity. How much is the mass of a body? 2 kg. Right? And what about the velocity? We have just got the answer as 15. So 2 into 15 is 30 kg meter per second. This is the required change in momentum. This is a required change in momentum. Clear? Okay. Shall we go ahead? 30 kg meter per second. Okay. Next question. A force acts for 10 seconds on a stationary body of mass 100 kg, after which the force ceases to act. Ceases means it has been removed. The force has been removed. The body moves through a distance of 100 meter in the next 5 seconds. Calculate velocity acquired by the body, the acceleration produced by the force, and the magnitude of the force. So this is the numerical what has been put in front of us. So let us try to analyze the data and extract the data accordingly. So the force, first one, a force acts for 10 seconds. That means they have given us the time. Time is 10 seconds. Okay. That means the force applied for 10 seconds on a stationary body. Stationary body means the body is at rest. Initial velocity is 0 of mass 100 kg. Mass of a body is 100 kg, after which the force ceases to act. After which the force ceases to act. That means the force has been removed on this body. The force has been removed on this 100 kg body. A body moves through a certain distance of 100 meter. That means distance has been given 100 meter in the next 5 seconds. In the next 5 seconds, right? Calculate the velocity acquired by the body. They are asking us to calculate the velocity acquired by the body, right? So first one, they are asking us to find velocity. Suppose this is T1, 10 seconds, and T2 they have given is next 5 seconds. 5 seconds. Okay. They are asking us to find the velocity acquired by the body. First one, velocity acquired by the body. Second one, acceleration produced. Acceleration produced. And the third one, magnitude of force. Magnitude of force. We need to find velocity, acceleration and force. Okay. So shall we start? Now to find force, the formula for force is mass into acceleration. Formula for force is mass into acceleration, right? We do have mass, but we don't have acceleration. So for acceleration, what we can do? For acceleration, we can have kinematic equations, right? And for velocity, how to proceed for velocity now? What is the formula for acceleration? V minus u upon t, right? V minus u upon t. So A is equals to, what is V? They are asking us to find V. What is u? U is 0. And what about t? T, this acceleration produced for 10 seconds. So can I say V is equals to 10A, right? So let us assume this to be equation 1. Okay, V is equals to 10A. Now, one more data is given here, that the distance traveled is 100 meter for time is 5 seconds. Body moves through a distance of 100 meter in the next 5 seconds. So from this we can calculate speed, right? Speed means velocity only. Speed is distance upon time. What about distance is speed into time, right? Distance. How much is the distance? 100 meter. What about speed? Velocity is 10A. And what is the time? Time is next 5 seconds. That is 5 seconds. So from this we can calculate acceleration. Yeah. So what is the acceleration over here? Acceleration is 100 upon 10 into 5. 0, 0 cancel, 5 ones are 5 twos are. So what is the acceleration? 2 meter per second square. Okay, 2 meter per second square. What is the acceleration? 2 meter per second square. Okay, and we have got acceleration over here. Okay, what about velocity then? Velocity is V is equals to 10 times of acceleration, right? From this equation number 1, 10 times of acceleration. Acceleration is 2. Then velocity will be 10 into 2, 20 meter per second, right? Velocity is 20 meter per second. Acceleration is 2 meter per second. Now the last part is force. How to find force? By second law. Apply second law. What is second law? F is equals to ma. What is m? M over here is 100 kg, 100 kg of mass. So I'll write 100 kg into acceleration. What is acceleration? What we have just found out to be like 2 meter per second square. And what about force? 2 into 100 is 200 Newton. That is F is equals to 200 Newton, the required answer. Okay, F is equals to 200 Newton. Clear with this sum? Okay, let's take a quick revision of this sum. A force acts for 10 seconds. So that's why we have taken T1 as 10 seconds on a stationary body. Stationary means rest. Stationary means rest. Stationary means rest. Rest means initial velocity 0. Rest means initial velocity 0 of mass 100 kg. After which the force ceases to act. Ceases means it stops. Force is getting stopped over here or removed. Force has been removed to act, right? The body moves through a distance of 100 meter. We have taken that distance as 100 meter in the next 5 seconds. So we have taken T2 as 5 seconds, right? So here is T1 and here is T2. Okay. Then they are asking us to find the three things, that is the velocity required, the acceleration produced by the force and the magnitude of the force. So the velocity required is represented by V, acceleration produced is represented by A and force is represented by F. Clear? So for velocity, first one, for velocity, use this formula of acceleration. Acceleration is V minus U by T. You know acceleration? No, we don't know. So we have just simply put it as A only. What about final velocity? We don't know. They are asking us to find the final velocity. What about initial velocity? Initial velocity is 0. U is equals to 0. So we have taken 0. So what is the equation? Equation built for velocity is V is equals to 10 times of A. So we will use this V is equal to 10 times of A in the next part, that is speed is equal to distance upon time. Then distance is equal to speed into time, right? So distance is 100 meter traveling for 5 seconds. Then what will be the acceleration for there? And what about the velocity? Speed into time, velocity. This one is velocity. Okay. What about the velocity is 10A. So 10A we have taken here. From this calculation we have got acceleration, right? Acceleration to be 2 meter per second, right? 2 meter per second. And then from here, from this equation 1, V is equal to 10 times of A, we have achieved velocity. And what about force, magnitude of force? From the second law we know force is equals to mass into acceleration. Mass is 100 kg, right? And acceleration just we have got as 2 meter per second square. So 100 into 2 is 200 Newton. Okay, done with this question? Okay, chalo, next sum. 8th question. Figure 3.11 shows the velocity time graph of a particle of mass 100 gram moving in a straight line. Calculate the force acting on a particle. Here they have given us one graph, that is velocity versus time graph, and they have given us the information like mass of a particle of a mass m is equals to 100 gram, but this is in CGS. So can we convert it into SI unit, that is kg? How to convert gram into kg? Divided by 1000. This is kg. This is 0.1 kg. M is 0.1 kg. Calculate the force acting on a particle. Calculate the force acting on a particle. So for force, obviously we will use second law, F is equal to m into A. We do have m in the given data, but we don't have A. How to find A? So for that purpose, they have given us the graph over here, velocity with respect to time, right? It's a straight line. So at any point, the slope will be same only. So how to find acceleration? Acceleration formula is velocity upon time. So at any point, take any point on this graph. Suppose we are taking here velocity upon time. What is the velocity? 20 meter per second for 5 seconds. 20 meter per second square for 5 seconds. So velocity is 20 meter per second for 5 seconds. Gives me the acceleration. How much it will be? 5 ones are 5 fours are, that is 4 meter per second square. This is the acceleration required, 4 meter per second square. Okay, so the required acceleration is 4 meter per second square. Then what about force? Force is mass into acceleration. What is the mass over here is 100 gram, and we have converted into kg, that is 0.1. So this is 0.1 kg into 4. How much it will result as? 0.4 Newton. So the final answer is 0.4 Newton, which is the required answer. Done? Understood everyone? So the required answer, that is the force acting on a particle, is 0.4 Newton. Okay? Chalo, next question. Question number 9. A force acts for 0.1 second on a body of mass 2 kg. Initially at rest. The force is then withdrawn and the body moves with a velocity of 2 meter per second. Find the magnitude of force. They are asking us to find magnitude of force. Can you people try this? It's just like as we have done all these questions on Newton's second law. Okay? Try this one. First, understand the question. Second, extract the data. Third, use the appropriate formula. And fourth, calculation. Chalo. Let us start with the question. A force acts for 0.1 second. So what is this 0.1 second? Time. They have given us the time. That is, the force is acting only for 0.1 second on a body of mass 2 kg. What is the mass of the body? 2 kg. Okay. Initially at rest. Initially at rest means u is equals to 0. Initially at rest. The force is then withdrawn. Withdrawn means what? It is taken back. It is taken back. It is taken back, or we can simply say the force is removed. Okay. The force is then removed and the body moves with a velocity of 2 meter per second. That means final velocity after removal of force is 2 meter per second. Find the magnitude of force. Find the magnitude of force. So we know by Newton's second law of motion, F is equals to ma, right? We do have mass, but we don't have acceleration. Yes. So how to find acceleration? Simple. Just use the kinematic equation, that is A is equals to V minus U by T, that is final velocity minus initial velocity upon time, right? What about final velocity? Final velocity is 2 meter per second minus initial velocity. Initial velocity is 0 upon time. For how much time the force has been applied? That is 0.1. So this gives us the acceleration. that is 2 upon 0.1. So can I say it's 20 upon 1? So acceleration is 20 meter per second square, right? 20 meter per second square. Then what about we have got acceleration, then by using second law of motion, right, that is F is equal to ma, can I get the value of force, the required answer? Yes. Chalo, let's apply. F is equals to ma, m is given as 2 kg into acceleration, what we have found here as 20 meter per second square. 2 into 20 is 40 Newton. 2 into 20 is 40 Newton. Okay, 2 into 20 is 40 Newton. The required answer. Getting? Very simple questions. Very small questions. You just need to read or understood 3 formulas. What are the formulas that we have just gone through now? First one is linear momentum. What is the formula for linear momentum? It is denoted by P. P is equals to mass into velocity, right? Next formula what we have made over here is second law. F is equals to ma. What about third? Third is to find A. Average velocity is final velocity minus initial velocity upon total time, right? So these are the most common formulas what we have gone through this entire questions till now, what we have solved, right? Starting from first question, linear momentum P is equals to mv. Second question, same way, P is equals to mv. Third question, F is equal to ma, right? Fourth question, again F is equals to ma. Fifth question, again F is equals to ma. Sixth question, here we have got A is equals to V minus U by T. Seventh question, we have made multiple formulas like A is equal to V minus U by T, F is equals to ma, and so on. And here we have used A is equals to V by T through this graph, and here the same things, right? So by these 3 formulas, just get thorough with these 3 formulas and you are done with the required questions. Okay? Chalo, next question. A cricket ball of mass 100 gram moving at a speed, of 30 meter per second is brought to rest by a player in 0.03 seconds. Find the average force applied by the player. They are asking us to find average force applied by the player. Average force applied by the player. Is it easy? Yes. Okay. A cricket ball of mass 100 gram. 100 ग्राम का जो बॉल है एंड जिसका स्पीड जो है 30 मीटर पर सेकेंड इज बॉट टू अ रेस्ट बाय अ प्लेयर इन 0.03 seconds. They are asking us to find average force applied by the player. So let us extract the data now. First one, a cricket ball of mass 100 gram. So the given data, mass is given as 100 gram, but we don't want in gram, we want in kg. So how to convert gram to kg? 100 gram divided by 1000 kg. Very good. How much it will remain? 0.1 kg. Okay. Next, a cricket ball of 100 gram moving at a speed of 30 meter per second. Velocity is given. Initial velocity, it's not v, but it's initial velocity. Okay. U is 30 meter per second. Is brought to rest. Is brought to rest means final velocity is 0. Is brought to rest means final velocity is 0 and this one is initial velocity. Okay. So v is equals to 0 by a player in 0.03 seconds. So the time given over here is 0.03 seconds. They are asking us to find average force applied by the player. So what is the second law? Second law of motion, F is equals to ma. This is the second law of motion. So this is the second law of motion, F is equals to ma. So we do have mass, but we don't have acceleration. Simple. How we will get acceleration? Average acceleration is final velocity minus initial velocity upon time. Final velocity minus initial velocity upon time. What is the final velocity? Is 0. What about initial velocity? 30 meter per second. How much time? 0.03 seconds. Right? So 30 minus 30 upon 0.03. So can I say it as 30 into 100 upon 3? Right? 3 ones are 3 tens are. And what about acceleration is minus 1000 meter per second square. Why minus 1000 meter per second? Why here negative sign comes for acceleration? Because the acceleration is decreasing, or we can say it is not an acceleration but retardation. The decreasing acceleration is known as retardation. That is 1000 meter per second square. So we got the value of acceleration. Can we find the force, the average force, by the formula, that is F is equals to ma. F is equals to ma. What is mass? Mass is 0.1 kg into what about acceleration? Acceleration is 1000. We will just get, we'll take down only the magnitude only. So how much it will be like? 0.1 into 1000 is 100 Newton. This is the required answer. F is equals to 100 Newton is the required answer. Clear? F is equal to 100 Newton is the required answer. Getting what we have done over here? Nothing. Just apply the second law of motion, and then to find acceleration, we have got the formula as final velocity minus initial velocity upon time. That's it. It's very important formulae to be remembered. F is equals to ma and A is equals to V minus U by T. F is equals to ma and A is equals to V minus U by T. Next question. A car of mass 480 kg at a speed of 54 km per hour is stopped by applying brakes in 10 seconds. Right? The question goes like this: is a car of mass 40 kg moving at a speed of 54 km per hour is stopped by applying brakes in 10 seconds. Calculate the force applied by the brakes. They are asking us to find, calculate the force applied by the brakes, right? And the given data goes like M is equals to 480 kg. Do we need to convert this? No, because already the data given over here is in kg only, moving at a speed of 54 km per hour. That means velocity moving at a speed of 54 km per hour. 54 km per hour. Right? 54 km per hour. Is stopped by applying brakes. That means applying brakes is stopped. That means final velocity is 0. That means this data refers to initial velocity and the final velocity is 0 in 10 seconds. The time given over here is 10 seconds. Calculate the force applied by the brakes. Calculate the force applied by the brakes. So how to do? Force is equals to same concept, mass into acceleration. We do have mass but we don't have acceleration. Then find acceleration. What is the formula for acceleration? Now you tell me, what is the formula for acceleration? Final velocity minus initial velocity upon time. What is final velocity? Final velocity is 0 minus initial velocity. Initial velocity is 54 kilometer per hour. Yes. See here, this is 54 kilometer per hour. Right? This is 54 kilometer per hour and time is given in seconds. So we must convert this velocity into meter per second. Right? Into meter per second. So U is equals to 54 kilometer per hour. How to convert meter per second? Meter per second, that is 54 into 5 by 18. Right? 5 by 18. 5 by 18. So if I will simply calculate 18 into 3. How much is 18 into 3? Let's do this. 3 8s are 20. 3 8s are 24. 3 1s are 3. 4 5. 54. So can I say it's 18 1s are 18 3s are, right? And 3 5s are is 15 meter per second. So initial velocity is 15 meter per second. So first you need to convert this into meter per second, then only you apply. It will be easier for you to convert it forefront before only, and then you can apply in the formula. So this is 15 meter per second. This is 15 meter per second upon time is 10 seconds, right? So what will be the acceleration? Acceleration is minus 15 by 10, which is nothing but 1.5 meter per second square. If I'll take only magnitude, and negative sign implies the acceleration is decreasing, right? That means it's a retardation. Okay. Now, next, we have got the acceleration. Then how to find out force? By simply applying Newton's second law. F is equals to ma. So what is m? M is 480 kg, right? Into acceleration. What about acceleration? It is 1.5. This is 480 into 15 by 10. So that is 48 into 15, which is nothing but 720 Newton. The required answer is 720 Newton. Getting? Okay? Chalo. Next question. A bullet of mass 50 gram moving with an initial velocity 100 meter per second. A bullet of mass 50 gram. M is equals to 50 gram. So do we need to keep like this only or convert? We will convert in kg. So 50 by 1000, that is 0.05 kg. With an initial velocity 100 meter per second, strikes a wooden block and comes to rest after penetrating a distance of 2 centimeter. Strikes a wooden block and comes to rest after penetrating a distance. That means S is equal to 2 centimeter. Convert it into meter. That is 2 by 100. That is 0.02 meter. Okay. Calculate initial momentum of the bullet. Calculate initial momentum. Initial momentum. And comes to rest. That means this one is V. This one is U. And final comes to rest means V is equals to 0. Calculate the initial momentum. So let us calculate initial momentum first. Initial momentum. What is the formula for initial momentum? Mass into initial velocity. Mass into initial velocity. What is the mass over here? 0.05 kg into initial velocity is 100. 0.05 into 100. That is answer, final answer will be 5 kg meter per second. This is initial momentum. First one. Second, final momentum. Now you people tell me, final velocity is 0, then final momentum. What about final momentum will be 0 only. Final momentum, that is mass into final velocity, which is nothing but 0. Okay, this one and this one. Now third one, retardation caused by the wooden block. Retardation caused by the wooden block. A is equals to V minus U by T. A is equals to V minus U by T. A is equals to V minus U by T. A is equals to V minus U by T. A is equals to V. What is final velocity? Final velocity is 0. Initial velocity? Initial velocity is 100 meter per second upon T. Time is for they haven't given time. Okay, they haven't given time. So how to calculate? Time दिया है, नहीं दिया है. So how to calculate this? We can't use this formula then. Then what is the remaining part? How to calculate? You can go with distance. They have given us distance. So simply you can go with kinematic equation, that is V square is equal to U square plus 2AS. What is V square? 0. What about U square? U square is 100 ka square plus 2 into A into S. S is 2 centimeter, that is 0.02 meter. Okay. So if I'll take this over here, that means A is retardation, right? A is retardation. Retardation always have negative sign. Retardation always have negative sign. So can I say it's 100 ka square minus 2A into 0.02 is equals to 0. So that means 2 into 0.02 into A is equals to 100 ka square, right? Then what about A? A is equals to 100 into 100 upon 2 into 0.02. Okay, that is 2 ones are 2 50s are. Okay, and what about this? 2 ones are 2 25s are, and these 2 zeros goes like this. Then acceleration is 25 1 2 3 4 4 times 0, right? Meter per second square, or else I can write like 2.5 into 10 raised to 5 meter per second square, which is the required answer. 2.5 into 10 raised to 5 meter per second, right? Then yes, this one is wrong, this we can't take. Okay, what about next? ये acceleration का आंसर हमको मिल गया, right? First one initial momentum, we got the answer. Second one final momentum, we got the answer. Third one retardation, we got the answer. What about fourth one then? Resistive force exerted by the wooden block. Resistive force, चलो यहाँ पे करते हैं. Resistive force exerted by the wooden block is mass into acceleration, right? Mass of a body is 0.05 into acceleration. What is acceleration? That is 25 4 times 0. 25 4 times 0. Okay. Then what about this? It is nothing but 5 into 25 is 125, and these 2 zeros get cancelled. That means 2 zeros will get remained. Okay. 12500 Newton. The final answer. 12500 Newton. Clear with this point? Yes, everyone? Okay. Sure. Next one. A force causes an acceleration of 10 meter per second square. Let us extract the data. 10 meter per second square in a body of mass 500 gram. Mass कितना है? 500 gram. So let's convert into kg. 500 divided by 1000, which is nothing but 0.5 kg. Okay. What acceleration will be caused by the same force in a body of mass 5 kg? Okay. A force causes an acceleration 10 meter per second square. Let us say this acceleration is A1 in a body of mass 500 gram. Let us say this is M1. Now they are asking us to find what acceleration will cause. That means they are asking to find A2 by the same force. Here force, this F1 by the same force means here let us say F2. So F1 is equals to F and F2 is equals to F. Force are same by the same force in a body of mass 5 kg. Now the M2 is given as 5 kg. They are saying F1 is equals to F2. Then they are asking us to find the acceleration produced in second mass. So F1 we know F1 is equals to M1 A1, right? And F2 we know F2 is equals to M2 A2 by second law. And the question clearly says that both the forces are same. So F1 is equal to F2. So by this we can calculate A2, right? So everyone try with me. What about M1? M1 is 0.5 kg into A1. A1 is 10 meter per second square. What about M2? M2 is 5 into A2 that we need to calculate, right? So how to calculate A2? A2 is 0.5 into 10 upon 5. 0.5 into 10 is 5 only. 5 and 5 will get cancelled. The acceleration is 1 meter per second square. Clear with this? Acceleration is 1 meter per second square. Okay. Next question. This is the last question of this exercise. A car is moving with a uniform velocity 30 meter per second. Uniform velocity 30 meter per second. It is stopped in 2 seconds by applying force. That means it will be an initial velocity. Okay. A car is moving with a velocity, uniform velocity 30 meter per second. It is stopped. Stopped means final velocity will be like 0. Stopped in how many time? How much time? 2 seconds. That means t is equals to 2 seconds. Okay. By applying force of 1500 Newton, they have applied 1500 Newton force through its brakes. First one, calculate change in momentum. Here mass is given or what? Okay, calculate change in momentum. To calculate change in momentum, P is equals to mv. We do have V, but we don't have mass, right? So how to calculate mass? We have force. So F will be like mass into acceleration. And we don't have acceleration now. For acceleration, what is the formula? The general formula is V minus U by T. V minus U by T. What is the value for V is 0. Minus U is 30 upon T. T is 2 seconds. So acceleration, that is the retardation, comes to be minus 30 by 2, which is 1 za 15. That is acceleration is minus 15 meter per second square. Acceleration is 15 meter per second square, which is our second answer. The retardation produced in a car is 15 meter per second square. Okay, we have got this one, second answer as 15 meter per second square. And if I wanted to calculate force now, force is equals to mass into acceleration. But how to calculate mass now? Mass is force upon acceleration. How much is the force applied over here is 1500 100 up Newton upon acceleration. We have just calculated 15. 15 ones are, this one is 100. So mass of a body is 100 kg. Mass of a body is 100 kg, which is the third answer. C. The mass of kg is 100 kg. What remains? The first one, the change in momentum. Change in momentum. Shall I do it here itself? Change in momentum, mass into velocity. What is the mass? Mass is 100. And what about velocity? Velocity is 30 meter per second. So 100 into 30 is 3000 kg meter per second. This is the change in momentum as 3000 meter per second. Done with this? Okay. So we have calculated change in momentum, we have calculated retardation produced in a car, and as well as we have calculated the mass of a car. So this is all the numericals what we have covered in this video of this exercise, and in the next session we will be covering the next exercise numericals. Thank you.